All right, here we go. Problem number 13 from our 1316 homework number 2 in MyLab Math. They want us to find the amplitude, period, and the phase shift, graph the function, and some more stuff, okay? So the first thing that I want to do is I want to write down the standard form of a cosine function, and that formula is y equals a cosine bx plus c. That is your standard form of a cosine function where we can see a is 5, b is 6, and c is pi over 2. And with that information, we can start to find the amplitude, which is the absolute value of a. So in this case, the absolute value of 5 is 5, and that gives us an amplitude of 5. The period of a sine or a cosine, the period formula is 2 pi over b. In this case, b is 6, and 2/6 reduces to 1/3. So our period is going to be pi over 3. And using the fraction button, we should get our period correct. And last but not least, the phase shift. Whoops. Now the formula for the phase shift for a sine or a cosine is negative c over b. So in this case, c is positive pi over 2. So when I plug into the formula, it's going to be negative pi over 2 all over 6. And that's going to require the KCF. That's going to require the keep, change, flip. So here we have negative pi over 2. We're going to change division to multiplication. And we're going to take 6, which is understood to be 6 over 1, and we're going to flip it, okay? So KCF stands for keep, change, flip. Keep the top, change to multiplication, and flip the bottom. And then we can multiply straight across, and we're going to get negative pi over 12. As our phase shift, negative pi over 12. And if I input that correctly, whew, okay, so far so good. Now we're going to graph this manually, and then we will graph it electronically. So going through the 6-step process of graphing a sine or a cosine, step number 1 is to locate the starting point, and that is determined by your trig function, okay? So we know that cosine starts at the number in front, and the number in front of our trig function is 5. So our graph is going to start on the y-axis up at 5. Except there's a phase shift. That's step number 2 is phase shift. So since we have a phase shift, that means that this point is actually going to shift to the left because our phase shift is negative. It's going to shift to the left, negative pi over 12. Okay, so if I erase this, that point is no longer on the x-axis. It's still up at 5, but it had to be shifted to the left a pi over 12. Okay, so that's the second step, is to deal with the phase shift. The third step is to deal with the wavelength, which is the period. Okay, so now I need to ask you a question. I need to know how many twelfths make a third. Let's think about that. How many twelfths would equal a third? Okay, so if we get a common denominator here, 4 times 3 is 12, so I got to do the top. And that's going to tell me that it's going to take 4/12 to equal pi over 3. Okay, 4/12. So this space right here, this is a 12th. And I'm starting back here at negative pi over 12. So if I go to the origin, that's 1/12, 2/12, 3/12, 4/12. Okay, so this distance here is 4/12. But if I reduce that, that is pi over 3. And I don't know if you noticed or not, but what I've done is I've counted from where my graph is going to start to where it's going to finish, because I know the wavelength has to be pi over 3. And so if I go 4/12, that's going to get me 1 period. That's a pi over 3. And remember, you always finish where you start. So if I start up at 5, I'm going to finish up at 5. And the last thing I need to do is I need to figure out what to label that hash mark. Okay, so from the origin, how many 12ths did I go? From the origin, 1, 2, 3 12ths. So this would be 3/12 of a pi, 3 pi over 12, but that will reduce. 3/12 reduces to 1/4. 3 goes into 12 4 times, so I can reduce that to 1/4, okay? So now I know where this graph is going to start, and I know where it's going to finish, and that is my wavelength, okay? Believe it or not, all of that is just step number 3 for the period for the wavelength, okay? Now, step number 4 is from start to finish, I have to have 4 equal spaces. Well, 1, 2, 3, 4. I got them. I've got my 4 spaces, so that takes care of step number 4. And then for step number 5, I need to lay out my points. So since I'm starting up at 5, it's like I'm starting at the top of a hill. That means I need to go down, and then I'm going to go down again, and that's going to bottom out, so I have to head back up and back up again. And that's going to make a complete wave, okay? Going down and down, and then going up and up. That is one complete period. So let's label some of these critical points, okay? First of all, this first point, if we label it as an ordered pair, that would be negative pi over 12, comma 5, okay? This end point would be pi over 4, comma 5. That's the end point. Of course, we have the origin. I don't see any reason to label the origin. We have the origin, okay? This point right here, that's at 1 hash mark over, and each hash mark is a 12th of a pi. So that's going to be at 1/12 pi negative 5, okay? So then what is this hash mark? This point right here, okay? So that's 1/12, 2/12. Well, 2/12 reduces to a 1/6. And so that point there on the x-axis, that would be pi over 6, comma 0, and then pi over 4, comma 5. So that would be one complete period labeled. If we want another period, we would simply count another 4 spaces. Okay, so let's stretch this out. So we would go 1, 2, 3, 4, and continue the pattern going down, down, up, and up. And then you just make another cycle, like so, okay? And then we could continue to label these points, counting by 12ths, okay? So then this point here, that is pi over 4, which was how many 12ths? 3/12. So then this would be 1, 2, 3, 4 12. What is 4 twelfths reduced to? Pi over 3. And then this would be 5 twelfths at negative 5. And then this would be 6 twelfths. 6 twelfths is half of a pi. And then this last point up here would be 7 twelfths. And that's up at 5. Okay, so there's all of those critical points labeled. And now I think what I'm going to do, again, instead of going here, and I like to teach as much good stuff as I can. So what I'm going to do is I'm going to bring in Desmos, and we're going to check what we just did. Okay, so let's see here if I can minimize this to where I can see my function. All right, here we go. We're going to type in the function y equals 5 cosine parentheses 6x plus pi over 2. Enter. And then that gets us over. Now, the nice thing about Desmos is you can click on this graph and you can move it around. And if you want to scroll the scroll wheel, you can zoom in and out. Super nice, okay? Now, let's figure out what some of these points are and see if I'm right. There's the origin. This point, look at it, it's negative pi over 12 comma 5, which is what I labeled that, negative pi over 12 comma 5, verified, okay? This point, pi over 12 negative 5, pi over 4 and 5, bam, bam, and you can click on all of these points and see what they are, okay? And then these here in the middle, pi over 6 and 0, pi over 3 and 0. Did I have those, pi over 3 and pi over 6 and 0? Let's see here. I didn't label this one. There's pi over 6 and 0 right there. Oh, there's pi over 3 and 0 right there. I had that labeled. So all of these points that I came up with manually with Desmos, they can be verified electronically. Super easy. All you got to do is type in this function, and then you just click on the critical points, and it verifies what those ordered pairs are. Man, that is super nice, okay? Welcome to Desmos. All right, now let's finish this problem. We're going to graph, and this function was a cosine, so we want to pick the cosine tool, click on the graph, and we're going to increase the amplitude to 5. We're going to change the period to, what was the period? Pi over 3. And the phase shift was negative pi, negative pi over 12. And we do not need to reflect across the x-axis because the original number in front was positive. The value of a, the coefficient, was positive. If it was negative, you would need to reflect over the x-axis, but it wasn't. And so we're going to click there. And I want you to notice this graph here. If I check it against Desmos, look at that. Similar, very, in fact, they're the same. They're exactly the same graph. So that verifies that this is correct. Man, what a long problem, but I hope all of that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.